Is it okay?
Yes, sir.
Okay. See if you have your simulation in your hand, start do it. Else, simply note down the procedures alone. Okay. Let me project the screen. Is it visible? Is it my screen is visible, dear students?
Yes, sir.
Yes. Okay. Experiment number 5. Last class itself, I told what are the things you need to do up to the construction of your circuit diagram. So in the construction of the circuit diagram, you need to remember only one point. Can anyone tell me what is the difference between our previous experiments and this particular experiment? What is the change in the previous experiment and this current experiment? This transistor. Am I correct, sir? The transistor alone is the major difference. You need to find it from the multisim. I will show you from where you need to fetch at the end of the session. Let me finish the procedures. Okay. If you have a record note also, have your record, lab record, and make a change in the transistor number in the record too. Okay. Yes. How many of them tried this? How many of them tried this reading? See, we need to connect two probes. One is the input probe, another one is the output probe. Okay. The input voltage, simply you keep it as a 20 millivolt and 1 kilohertz. Dear students, note down as a hint or the flow chart. Hint or flow chart konjam eludhi vechiko. Okay va? Input voltage 20 millivolt, frequency 1 kilohertz, then input probe and output probe. Input probe and output probe. Then your biasing voltage is 15 volt. Please say yes if you have note down these important points. Quick. Last class stuff I told. Anyhow, let me repeat once again the basic procedures. Please say yes if you have note down. Yes, sir.
Yes,
Is
sir.
it recording happening in the B class? Is it recording happening in the B class?
Yes,
Yes, sir. Recording, sir.
Okay. So input parameter these two, then the biasing voltage, then the probe, and also name the probe accordingly. Vs is the signal voltage, Vout is the output voltage. That's all. Remaining things are you will set it by your own. No issue on that. Now I need to change the frequency and I need to take the output voltage. Okay, that is the first step. We are going to change the frequency and we are going to measure the output voltage with respect to the change in the frequency. What is that? That is our tabulation. See here, this is our tabulation. Okay, ma'am. So in the tabulation, can anyone tell me which one is the fixed one for the entire experiment? Which one is the fixed one for the entire experiment? Which parameter is the fixed one?
Vs.
Input signal.
Signal. How much you will write? Can anyone tell me? How much you will
20.
write? This 20, copy and paste it over here. 20 millivolt. Is it clear, sir? Is it clear, sir? Yes.
Yes, sir.
Now we need to start change the frequency and accordingly we need to measure the output voltage. Okay. As usual, we will give you some set of readings. Before that, how to take the reading? See, these are all my two probes, signal probe and the output probe. Okay. Please observe what is the setting you need to keep in your simulation window. Please note it down. Go to this measurement label. Go to the measurement label. There you need to select what? You need to select what? Periodic. Okay, wow. There are two voltage probes. What is that? Signal probe and output probe. Am I clear, dear students? Am I clear?
Yes, sir.
In both the probe, what is the mode you need to set to measure the quantity? Instantaneous or periodic?
Periodic.
Okay, wow. So periodic you need to measure. Okay, periodic alone you click it. Okay, that's all. Then how will start simulate? What is the mode you need to keep? Note down. Keep it in the interactive mode. interactive mode. நான் 2-3 times சொல்றேன், எழுதி வெச்சிக்கோ. Keep it in the interactive mode. Then click the play button. Click the play button. Once you click the play button, you will get the readings as shown in the image. Am I correct, sir? Am I correct, sir? You will get the input parameters. What are the parameters? Can anyone zoom your view and tell me?
Okay, I'll ask all the participants to submit the.
Kana 1 minute. Kana 1 minute.
The certificates will only be issued to the participants who have submitted who has attempted.
Wait a minute. Sorry for that. Now it is okay. Now the screen is visible. Hello.
Okay.
Okay. Now yes. Tell me. What are all the parameters? You can view it over here. The input and output. Can anyone zoom and tell what are all things in there? Peak to peak. In the label, I am asking the measurement label. The measurement label. RMS. Then average and the frequency. Okay. Listen. I need to write the frequency value and the output voltage. Here I am having too many parameters. Am I correct, sir? Too many parameters. Here it is simple. Frequency is available here. Out of these 3 readings, what you need to take? Please observe the animation. The first one, after selecting everything, click a play. Thereby you will get this reading. Now this is my signal input voltage. Am I correct, sir? This is my signal output voltage. Okay. இது எவ்வளவு வருது சார்? சிக்னல் இன்புட் வோல்டேஜ் எவ்வளவு வருது? How much it is? Hello.
40 millivolt.
Peak to peak எவ்வளவு வருது? 40 volt வருது. கரெக்ட்டா? That where you need to write. அண்ணா கொஞ்சம் பாரு, க்ளோஸ் அப் பாரு. இந்த 40 millivolt எங்க எழுதணும் சார்? Peak to peak எழுதிக்கலாம். Okay, we are not going to write this 20 millivolt. And previous I said it is 20 millivolt. Okay, but sorry for that. We are going to take only peak to peak value. Please observe. This is my input peak to. Why it is 40? Here I am keeping only 20 volt. Why it is 40? Can anyone tell me? Can anyone tell me why it is 40? See, this is 20. Peak to peak means how much you will get? 20 plus 20. Evola sir varum? 20 plus 20 evola varum? Are you getting the same 40 over here? So here, yes, whatever the voltage represented, we are going to keep it as a peak to peak. Note பண்ணி வெச்சுக்கோ. Peak to peak voltages மட்டும் எழுதுனா போதும். Okay va? Yes. Let me show the animation slowly. First you will note down this value and write it there in the signal voltage. Then frequency. Here is the frequency. Am I correct, sir? Initially we are going to keep it as a 50 hertz. So the first reading 50 hertz. First reading 50 hertz. 50 hertz. Write it in the frequency row. Is it okay up to this? Is it okay up to this? Can anyone tell me what is the output voltage in this reading? Can anyone tell me what is the output voltage you will write? What is the output voltage you will write? 58.7 millivolt. Nothing but 0.058 volt. Note down the reading here. Is it clear, dear students, how to write these 3 readings? Is it clear how to get these 3 readings? Here from the frequency, then input signal, peak to peak value, output signal, peak to peak value. Any doubt in this, please ask. Any doubt in this, please ask. Quick. Is that doubt irukka? Kana eda doubt irukka?
No sir.
Doubt illalla? Screenshot எடுத்துக்கோ. Screenshot எடுத்து வெச்சுக்கோ. அவ்வளவுதான். இந்த ரீடிங்ஸ் எவ்வளவு ஸ்டெப்ஸ்ல எடுக்கணும் சார்? That we will show it in the next slide. Take the screenshot of this table. Take down the screenshot of the table. This frequency column is fixed. We given the frequency value. That means what? 50 hertz, 100 hertz, 500, 800, 1 kilohertz, 1.5 kilohertz, 2 kilohertz, 3 kilohertz, 5, 10, 30, 50, 100, 200, 500, 750. These are all kilohertz. These are all kilohertz. Can anyone tell me what is the next range we gave it? 10 to the power 6. What is that?
Megahertz, sir.
Megahertz. Very good. 1 megahertz, 5 megahertz, and 10 megahertz. That's all. So this is the fixed one. Then your task is to fill the output voltages alone. First, you need to set the frequency in the circuit. You need to set the frequency in the circuit. Then you have to click the play button. Then you have to note down only the output voltage. Note down the output voltage in the, here. Then, can anyone tell me how you will calculate the gain, voltage gain AV? How you will calculate the voltage gain AV? How you will
Output
calculate
voltage by input voltage.
output voltage by divided by input signal? What is my output voltage, sir? What is my output voltage?
0.058.
0.058. 0.058 volt. What is the input voltage, dear students?
40 into 10 power minus 3 volt.
Actually, it is 40 into 10 to the power minus 3. If you are having calculator, you can write it over here. 40 into 10 to the power minus 3. Or else 0.04. Correct, sir? 0.04. Can anyone divide and tell me the answer, please? Can anyone divide and tell me the answer, please? Output voltage divided by input voltage. Solunga paakalam. How much you are getting, sir?
1.45, sir.
Evala sir varudhu?
1.45.
Are you getting 1.45? Are you getting 1.45? Yes, that's all. Note down this calculation. Please note down this calculation. This is the single step you need to do. Then I need to convert this into decibel. How to convert? What is the formula? What is the formula? 20 log of this value. Am I correct? This value. Please take your calculator and anyone please find and tell. 20 log of
3.2273, sir.
3.2273. 3.2273. We need only 3-digit accuracy. So we will take it as a 3.227. Is it clear, dear student? Is it clear how to calculate the gain and the gain in decibel? Take a screenshot of this. Let me erase this disturbance arrow. Can you take down the steps how to calculate? Yes, sir. Any doubt in this? Any doubt in this? You can ask. Let me ask. Say example. If I am getting 0.0, if I am getting 0.04 voltage as output, what is the gain? What is the gain?
1, sir.
1. So in this case, the output voltage is 0.04. My input is also 0.04. Therefore, gain is 1. Okay. If you convert it into decibel, how much you will get, sir? Can anyone calculate and tell?
0.
Sir, 0,
20
sir.
log of 20 log of 1. Calculator panna vendam. Log 1 0. It will be 0. I hope this is clear to you people. What you need to do, let me repeat once again. You need to change the frequency. First step. Note down the voltage value. Then change the third frequency. Note down the voltage value. Okay. Then step by step change the frequency and note down. This alone is very, very important. These two are simple calculations. That's all. 30% of your task is over. And if you any people having the doubt on that, you can stop me. Else, I will proceed further. Yes. Shall I proceed further?
Yes, sir.
Yes. Have you note down this? Have you took the screenshot of this one? Have you took the screenshot of this one?
Yes, sir.
Yes. Okay. Yes. Then now you may ask. Sir. So from the frequency and the amplitude in decibel, using these two reading, is it we need to plot the graph? Is it we need to plot the graph? Now listen, this is the logarithmic scale. This is logarithmic scale. Correct? Sorry. Oh, sorry. I did a very big mistake. Frequency. Sorry, correct. Sorry, correct. X-axis only the logarithmic scale. So frequency எப்படி இருக்கு சார்? Frequency நமக்கு எப்படி இருக்கு? ஃபிக்ஸ்டா இருக்கு. இது வந்து டெசிபல் லாகரிதமிக் ஸ்கேல் இருக்கு. ஸோ இதெல்லாம் நாங்கள் கிராஃப் ஷீட்ல வந்து யூ ஹாவ் அ செமி லாக் கிராஃப் ஷீட். தெரிஞ்சு வச்சுக்கோ. செமி லாக் ஒரு ஸ்கேல் லீனியர் ஸ்கேலா இருக்கும், இன்னொரு ஸ்கேல் எப்படி இருக்கும்? லாகரிதமிக் ஸ்கேலா இருக்கும். நெட்ல அடிச்சுப்பாரு. நம்ம நார்மலா யூஸ் பண்ற கிராஃப் வந்து இட் இஸ் அ லீனியர் கிராஃப். ரெண்டுலையுமே வந்து லீனியர் வேல்யூஸ் தான் வைப்போம். ஓகேவா? இங்க ஒன்னு லீனியர், இன்னொன்னு வந்து என்னது லாகரிதமிக் ஸ்கேல் அப்படின்னால அந்த கிராஃப்க்கு என்ன பேரு? செமி லாக் கிராஃப் ஷீட். யூ நோ நீட் டு டூ தட் அண்ட் ஆல். திஸ் சாஃப்ட்வேர் ஹாஸ் அ ஒன் வண்டர்ஃபுல் ஃபீச்சர் கால் ஏசி ஸ்வீப். நம்ம இது வரைக்கும் சிமுலேட் பண்ணும்போது இந்த ஆப்ஷன் பார்த்திருக்கோமா எங்கேயாவது ஏசி ஸ்வீப்னு? இதை டிராப் டவுன் பண்ணும்போது ஏசி ஸ்வீப்னு வரும். பார்த்திருக்கோமா? Have you come across that circumstance? Have you come across that circumstance? Please
Yes,
say
sir.
yes or no. Simulate பண்ணும்போது இதை டிராப் பண்ணா இங்க பாரு, இன்டராக்டிவ் டிரான்சியன்ட் ஏசி ஸ்வீப்னு இருக்கா சார்? Is it there? See, now I am going to click AC sweep and I am going to click the play button. What is happening? Can anyone observe and tell me? The system itself plotting the waveform. Am I correct, sir? System itself taking the x-axis and the y-axis and it is giving the waveform. Is it V plotted or system plotted?
System.
How much time it took to draw the plot? Fraction of seconds. Correct, sir? So in the graph, what are all the settings you need to do? Okay, that I will teach you now. Okay, I will skip the theory portions and all. Okay, see, where is this one? If you want to take a definition of this, please note down. The AC sweep simulation calculates the frequency response of linear circuits. How to select the AC sweep menu? See, select the AC sweep menu and then click run. Okay, AC sweep drop down pannu, AC sweep select pannu and then click play button, or else you have a shortcut key to run the simulation, that is control plus R. Note பண்ணிக்கோ. ஆனா வெறும் R press பண்ணா என்ன வரும்? Can anyone tell me? In a multisim, if you simply press R, what you will get?
Resistor, sir.
Resistor. Very good. Control plus R வந்து என்ன சார் வரும்? Play. You can start run the simulation. Kana இத மட்டும் கொஞ்சம் நோட் பண்ணிக்கணும் க்ளோஸா. Okay, see, if you click the play button, with no time you will get the graph like this. Is it we got the same? See, is it anyone getting the same kind of waveform from your side? Hello?
Yes, sir.
யாருக்காவது இதே ரீடிங் வந்து இதே மாதிரி வேவ்ஃபார்ம் வந்திருக்கா?
Yes, sir.
Yes, it's not look like our actual waveform what we have studied. Am I correct? In our actual studied waveform, we don't have the negative portion. Zero ல இருந்து இப்படி ஸ்டார்ட் ஆகும், இப்படி போய் இப்படி waveform வரும். Am I correct, sir?
Yes, sir.
Okay, so for that we are going to do some adjustment. Okay, we can say it as adjustment because we are not getting exactly. So how to skip this portion? So we are going to do some scaling adjustment for that. Okay, what are the scaling adjustment? Please note down. Okay, after getting the graph, please observe. After getting the graph, okay, click. See, we need, see this one, you know, correct, sir? In the portion matanda enakku venu varayirthukku, correct? Remaining portion I don't want. Am I correct, sir? Am I correct, sir? This is the model graph. The output waveform almost similar to our model graph, but I need to eliminate this portion. Am I correct? Am I correct? I
Yes,
need
sir.
to keep this
Yes,
portion
sir.
in my screen setting. Okay, how to do that? So, okay, so how we are going to achieve this? We will see now. We will see now. Please note down. Go to this grapher, then go to setting. Then once you click setting, you will get this menu. Is it everyone getting this menu? Whoever doing simulation right now? Are you people getting this menu? Please read and tell me what are all the things appears there. One is phase Vs, another one,
Mark yes, sir.
magnitude Vs, another one.
Phase V naught.
Then, so that means what? That's mean what? This selection, see, listen, here you have one blue color continuous line, then one blue color shaded discontinuous line. Am I correct? Similarly, green color continuous line and green color discontinuous line. So it is labeled over here. Can you closely watch here? Magnitude, it is a continuous line. Magnitude of input signal, Vs is green. The magnitude of output signal is the blue continuous line. Then phase of Vs. Phase of Vs is the discontinuous green line. Then discontinuous blue line is the phase of output voltage. That means in this we are going to have two parameters. One is the phase and magnitude. Phase and magnitude. Actually, we are interested to have only the output magnitude. Can anyone tell me what I need to do for that? What I need to do for that? What I need to do for that? I need only this waveform. What I need to do in this checkbox? What I need to do in the checkbox? Can anyone unmute and tell, please?
So rather than output magnitude, we have to uncheck all the.
That's all. That's all. Other than output magnitude, I need to uncheck remaining things. Okay, I'm going to uncheck the remaining things. Thereby, you will have only this. Now I'm getting only one waveform. Is it clear to everyone, sir? Is it clear to everyone? I repeat the step once again. Go to the grapher menu, go to the grapher, then click the item. Thereby you will get these menus. In that, uncheck these three unwanted things and ensure you have selected this one. Thereby you will get only the magnitude output. Can you see? Can you see? Previously there were three. Now it is only one. Now it is only one. Can anyone tell me? Now I want to see the reading only this portion I are interested to watch. What I need to do? What is the setting modification I need to do? Whether I need to do the changing modification in the x-axis or in the y-axis. எதுல நான் change பண்ணணும்? Anyone please? எங்க change பண்ணணும் நம்ம setting? X-axisல y-axisல? We need to do the change in the y-axis scale. Okay, that I will show you now. See, go to, after selecting this, you will get this. Okay, wow. Before that, can you read what is the quantity present in the x-axis? What is the quantity present in the x-axis, sir?
Frequency.
X-axis என்ன quantity இருக்கு? நான் zoom பண்ணி காட்டியிருக்கேன். என்னன்னு படி? x-axisல என்ன இருக்கு?
Frequency.
Frequency. What is in your model graph? What is in your model graph? Model graph la enna irukku?
Frequency, sir.
Frequency. அப்ப அதுல ஒண்ணும் problem இல்ல. ஓகேவா? Okay. Now you check the y axis please. Wait a minute. X axis பார்த்துட்டேன். ஓகேவா? Y axis க்கு it is in the logarithmic scale. கரெக்டா சார்? என்ன ஸ்கேல்ல இருக்குது y axis?
Logarithmic scale, sir.
இத நான் actually I supposed to change it into decibel. இது என்னவா மாத்தணும் நானு? I need to change it into decibel. Decibel மாத்தலாமா? Decibel எப்படி மாத்துறது சார்? How to change it into decibel? How to change it decibel? Click this. You will get the drop down menu. In that you will find decibel. Check பண்ணி பாருங்க. Check பண்ணி பாருங்க. Are you getting the decibel? Are you getting the decibel menu? Are you getting the decibel menu? See, now it is in the logarithmic scale. நீ graph plot பண்ணினா similar graph sheet வாங்கி logarithmic scale use பண்ணி தான் plot பண்ணுவேன். ஓகேவா? நம்ம since the software giving some additional feature to measure in the decibel itself, I'm going to plot the graph at the decibel. Okay. So how to change? Click the decibel. Click the decibel. Where I need to click the decibel? இங்க magnitude ல போய் பார்க்கணும். Magnitude ல போனேன்னா ஓகேவா? So இங்க வந்து vertical scale ல logarithmic scale ல இருக்கும். This is the vertical component. Am I correct? This is the vertical component. So vertical ல change it into decibel. Decibel ல மாத்தியாச்சா? Is it anyone changed it into decibel? Now you check. Now you check. Now you check. It is changed into decibel. In the here also, if you check, the magnitude will be in decibel. Am I clear, sir? Am I clear to you? Take a screenshot of this one. The y-axis must be decibel in our case. Is it okay, sir? You can say yes or no.
Yes, sir.
Yes, sir.
Decibel select பண்ணிட்டா இங்க decibel வந்துருச்சா? Okay? Decibel select பண்ணிட்டோமா? அவ்வளவுதான். இதுக்கு அடுத்து last ஒரே ஒரு setting what we need to do, we need to skip the negative portion. Why I am getting the negative portion? If you closely observe here, the decibel ranges by default from -60 to 40. Can anyone tell me? I want to eliminate the negative portion. Thereby, what I need to substitute in the minimum value?
0,
What
sir.
zero. We need to substitute 0. Shall we substitute 0 and check, please? Shall we substitute 0 and check, please? Kana இந்த parameter எங்க போய் எடுப்பீங்க சார்? Axisல போய் எடுக்கணும். ஓகேவா? இந்த parameter எடுக்க தெரியாதவங்க நோட் பண்ணிக்கோ. Axis-ஐ click பண்ணி அதுல vertical component-ஐ பார்த்து அதுல decibel எடுத்து இதை change பண்ணணும். Is it anyone having the doubt in that? Is it anyone having the doubt? Hello, sir?
No, sir.
Are you changed that into 0? Are you changed that into 0 now? If you change 0, if you change it into 0, immediately you will get the waveform like this. Is it okay now? Is it okay now? Is it okay now? It's now we got the waveform almost similar to our theoretical value, almost equal to our theoretical value. Okay, ma? Yes. Then the waveform வரைஞ்சதுக்கு அப்புறம் அதுல பார்த்தேன்னா உனக்கு என்ன மார்க் பண்ணிருக்காங்க சார்? Can anyone tell me? So this is my output response. Then they will have one dotted line for 3 dB. இது மாதிரி எங்க மார்க் பண்ணிருக்கா சார்? 3 dB மார்க் பண்ணிருக்கா? அந்த 3 dB line எங்க டச் ஆகுதோ that is the lower cutoff frequency. This is the higher cutoff frequency. Am I correct? Can you watch the waveform like that? Here you are having some decibel. How much you need to come down? How much decibel we need to come down? எவ்வளவு decibel கீழே down வரணும்? How
3
much?
decibel.
3 decibel. Then assume I am marking one line over here. Now you tell me which one is the lower cutoff frequency. How you will find? How you will find? Let me consider this as a point A, this as a point B. Please tell how you will find the lower cutoff frequency and upper cutoff frequency. What you have to do? You need to draw one parallel line. Y-axis parallel, you need to draw one dotted line. It will touch your y-axis. Similarly, here you need to draw one parallel line. It will touch the x-axis. So this is the lower cutoff frequency. This is the higher cutoff frequency. Can anyone tell me what is the bandwidth? What is the bandwidth? How you will calculate the bandwidth then? How you will calculate the bandwidth then? Bandwidth.
Higher cutoff frequency minus lower cutoff frequency.
Now you listen. We are not going to do the marking and all in the graph. The system itself, such a way it is designed that you have a cursor. Can anyone see the cursor in your simulation window? Cursor nor menu paaka mudiyudha. In that you will find x-axis and y-axis. Please say yes if you can view that. Click cursor. There you will have one drop down box, x and y axis. What is that? Is it everyone can see the x and y axis? நாங்க simulation போயிட்டு வந்தா லேட் ஆயிரும்டா. அதனால தான் நான் அப்படியே கன்டினியூ பண்ணி போயிட்டு இருக்கேன். See, I unchecked everything. So I am getting this waveform. Then compare, keep it as a 0. Keep it as a 0. Okay. Only I am getting this. Then now again click the item. Then go down. Go little up. Here you will find cursor. Cursor nirka. In that cursor, if you drop down, cursor enga irukku theriyudha sir? The magnitude just below. If you click, you will find x-axis and y-axis. Now I am pressing y-axis. அப்ப எதை மெஷர் பண்ணுது? y-axis ஓட குவாண்டிட்டியை மெஷர் பண்ணுது. கரெக்டா சார்? கரெக்டா சார்? y-axisல என்ன டிஃபரன்ஸ் இருக்குன்னு மெஷர் பண்ணுது. If I change it into x-axis, you can find the x-axis values. Is it clear, dear students? Is it clear?
Yes,
Is
sir.
it clear? Is it clear? See, and one more thing, there will be some reading under that. We are unable to watch that. So for that purpose, we are doing to do one thing. It is there. It is at the bottom. I need to bring the reading little up. Thereby, I am going to click this magnitude also. Now everyone closely watch at the bottom of the window. Is it you can able to view the cursor 1 decibel value, cursor 2 decibel value, and the change in the frequency. Can you see it at the bottom, please? Paaka mudiyudha? Paaka mudiyudha? In the magic I am going to show it in the PPT in a clear way. Okay, please note it down. First you need to select the y-axis. Why y-axis? First I need to set this 3 decibel. So the 3 decibel set பண்ணனும்னா இது y-axis quantity. அத நான் first set பண்ணனும். Then listen how I am going to set that one. Y-axis click பண்ணிக்கோ. Immediate cursor will appear like this. Then y-axis select பண்ணதுக்கு அப்புறம் what you have to do, you unable to view this readings. You unable to view the reading. Am I correct? You unable to read the reading. How you will get the reading? How you will get the reading? How you will get the reading?
By checking the magnitude of ES.
Checking the magnitude of the one more waveform. Therefore, select the magnitude of VS2. We no need of the VS2, but in the software there is one small problem. If you are clicking more than 2 quantity, then only the readings are visible to the designer. Okay, sir? Yes. நான் கொஞ்சம் லிமிட் தாண்டி போயிட்டு இருக்கேன் நினைக்கிறேன். 4:10 ஒரு 10 மினிட்ஸ்ல முடிச்சு கொடுத்துட்டுமா? நீ அப்பதான் நீ உட்காந்து பிராக்டிஸ் பண்றதுக்கு ஒரு 2-3 days கிடைக்கும். டவுட் இருந்தா என்கிட்ட கேட்கலாம். கரெக்டா? நான் முடிச்சு கொடுக்கட்டுமா?
Yes, sir.
ஓகே. Yes, sir. அதுவும் ஓகேன்றிச்சு, நீங்களும் ஓகேன்றீங்க. Thank you. So now very simple. Let me tell you the procedure very simple. Fix the y-axis cursor. இந்த பாயிண்ட்ல வை. இந்த 2 பாயிண்ட்டை நீ நோட் பண்ணிக்கணும். உனக்கு தெரியும் x axis cursor நம்ம செலக்ட் பண்ணி முடிச்சிட்டு y axis கிளிக் பண்ணும்போது x axis என்ன ஆயிருது, டிஸப்பியர் ஆயிருது. கரெக்டா? அப்ப நான் எப்படி சார் பண்றது அது? நானு I will give you hint to you people. Do one thing. Okay, do one thing. இந்த frequency calculation நான் கடைசியா சொல்லி தரேன். ஓகேவா? Do one thing. Set your C2 cursor at the topmost waveform. Then set the C1 cursor at the என்ன இதுல cursor வைக்கணும்? How you are going to decide? Check this change in frequency. Change in decibel இங்க தெரியுதா பாரு? இதுல 3 வரணும். இந்த del y ல you need to get the reading as a 3 decibel. What is del? Del y is nothing but C2 minus C1. அப்ப C2 ல ஒரு decibel இருக்கு, C1 ல ஒரு decibel. C2 decibel is 32.9. C1 decibel is 35.9. How to find the del y? You need to subtract it from C2 to C1. Correct? அதெல்லாம் நீ எதுவுமே பண்ண வேண்டாம். The system will take care. Okay. Just fix this one, fix this one, fix this one. Then move the C1 cursor gently and also closely observe this change. Once you check it as a 3, stop cursor. Stop பண்ணிட்டியா? Stop பண்ணிட்டியா? Now I need to note down இந்த minus 3 dB இந்த கதை இதுக்கு மேட்ச் ஆகுதா சார்? Is it matches with this? Is it matches with this? Is it matches this with? Yes சொல்லு, நோ சொல்லு கண்ணு. இந்த 3 del 3 dB க்கு நம்ம செட் பண்ணிருக்கோம். del 3 dB செட் பண்ணிருக்கோம். This 3 dB matches with my model waveform. Correct sir?
Yes, sir.
See, if you completed this, your task is to find these 2 points. இது எப்படி சார் ஃபைண்ட் பண்றது? கண்ணா நீங்க பாரு, இது the moment at which if you change your cursor to y axis to x axis, because நம்மளோட டாஸ்க் வந்து இந்த ரெண்டு frequency கண்டுபிடிக்கணும். அப்ப நம்ம வந்து we will get the help of the x axis cursor. So x axis cursor நான் இங்க கொண்டு வந்து இப்படி நிறுத்தணும். If I get the x axis, immediately y axis will get disappear. அப்ப நீ என்ன பண்ணுனா, keep your thumb finger or any one pointer on display ல குத்தி உடைச்சிராத. சரியா? அந்த finger கொண்டு போய் அந்த particular cross point ல கை வச்சுக்கோ. So that is this point. Okay? Keep your finger in this point. Then you change the cursor mode. Okay, cursor mode change பண்ண அப்படின்னா, see A, B is the point. There you need to keep your x-axis cursor. Okay, first time we need to set with the y-axis. ஒரு time set பண்ணிட்டு விட்டுரு. Then you come to the x-axis cursor, note down these 2 points, then change the cursor position to x-axis. Okay, click the x-axis, then immediately you will get the cursor like this. Can anyone tell me, is it my previous references are present in the screen or is it disappears? இருக்குதா, disappear ஆயிடுச்சா?
Disappear sir.
Disappear. அப்ப நீ என்ன பண்ணுனா, இந்த பாயிண்ட நீ ஏதாவது பண்ணி மானிட்டர்ல கை வச்சுக்கோ, இல்ல மொபைல் போன்ல அந்த பாயிண்ட்ல கை வச்சிட்டு you need to keep the cursor in such a way that first point ல C1 வச்சுக்கோ, second point ல C2 வச்சுக்கோ. C2 frequency is here, C1 frequency is here. This is your del x. Can anyone tell me the del x equal to what? Del x equal to what? Del x equal to what?
C2 minus C1.
Okay. Technical word, what we have studied? C2 minus C1. What is the technical word? What is the technical word? What is the technical word? Cutoff frequency. See, the C2 is the cutoff frequency, higher cutoff frequency. C1 is the lower cutoff frequency. Then what is the del x?
Bandwidth.
That's all your honor. That is your bandwidth. I know, I hope you are having this kind of table in your record notebook. Am I correct? This kind of table at the end of the experiment. You need to write some readings over here. Am I correct? Am I correct?
Yes, sir.
Am I correct? Can anyone tell me what are the readings you will write here? What is your higher cutoff frequency? What is your lower cutoff frequency? What is your bandwidth? Higher cutoff frequency is C1 or C2?
C2.
C2, very good. Higher cutoff frequency is C2. Lower cutoff frequency is
C1.
C1. Bandwidth is del X.
Del.
பாருங்க இப்ப க்ளோஸா வாட்ச் பண்ணுங்க. This is C1 reading 1.67 kilohertz. Where I need to place, sir? Where I need to place? This is higher cutoff frequency 431.36 kilohertz. Where I need to write this frequency? This is what? This is what? 429.69 kilohertz. What is this? What is this?
Bandwidth.
Bandwidth.
Now you closely watch. Now you closely watch where these values are moving. Yes, my C1 is in lower cutoff frequency. Is it clear, dear students? Is it
Yes,
clear,
sir.
dear students? Is it clear? Then C2 reading, C2 reading, higher cutoff frequency. C2 reading, higher cutoff frequency. Then bandwidth. Is it clear up to this? Is it clear up to this?
Yes, sir.
That's all. That's all. With this, I am going to wind up. This is with this I am going to wind up. In the next lab class. Okay, this is your bandwidth. Correct, sir? This is your bandwidth. So try to finish up to this. If possible, try to find how to draw these waveforms. இது ஒரு 2 minutes தான் ஆகும். நான் கண்ணில் காட்டிட்டு வைண்ட் அப் பண்ணிட்டுமா இல்லை நீ ட்ரை பண்றியா? How to draw these two waveforms? Shall I? Okay, let me show and finish it. How to draw these two waveforms? Very simple. After finishing this, okay, va? Hello? Hello?
Yes, sir.
Midband frequency you need to find. Midband frequency அப்படின்னா நல்லா க்ளோஸா வாட்ச் பண்ணிக்கோ. Midband frequency is the one at the time your gain is almost constant இருக்கணும். புரியுதா? இந்த போர்ஷன் தெரியுதா? Bandwidth is different, midband gain is difference. புரியுதா? midband gain almost constant இருக்கணும். பேண்ட்வித்ல லைட்டா ஒரு சின்ன லீனியர் இன்க்ரீஸ் அண்ட் டிக்ரீஸ் இருக்கு. ஸோ இந்த ரேஞ்சில் ஒரு ஃப்ரீக்வன்சி யூ நீட் டு சூஸ். லெட் மீ சூஸ் இட் as a 10 kilohertz. First point, how to draw these two input output waveforms. First point, you need to choose the midband frequency. Simply you take it as a 10 kilohertz. Point number 1. Where we are going to set this frequency? Simply you are going to set the frequency over here. Okay, then in the same circuit diagram, set the midband frequency. After that, select this mode as a interactive and also confirm here it is in periodic. Okay, then you need to start play button. You need to click play button. At the time the simulation will be started. Then you need to check the graph output. If you click graph output, you will get the waveform like this. Can anyone tell me what is your blue color waveform? What is your green color waveform? What is your blue color waveform? What is your green color waveform?
Blue color output, sir. Green color
You need to
input,
find
sir.
this labeling. Blue color is output. Green color is input. Okay. Input is low magnitude. Output is amplified. Am I correct, sir?
Yes, sir.
Yes, sir.
Am I correct, sir? Then listen. My input start from here to here like this. My output is going to negative. Why, sir? Why there is a 180-degree phase shift? Because it is an Inverting amplifier. Common emitter amplifier. Single stage common emitter amplifier is also called as an inverting amplifier. Is it you are getting the same kind of output here? If you want to get the same fashion of the output, you need to select this time into 100 microseconds per division. Note பண்ணிக்கோ. இந்த செட்டிங்ல வச்சினாதான் உன் waveform உன்னால இந்த கரெக்டான இந்த frequency waveformல பார்க்க முடியும். Note down this setting. Note down this setting. Then what else? What else? Magnitude for output voltage க்கு note பண்ணிக்கோ. Output voltage க்கு -2 to 2. Output voltage க்கு என்ன reading set பண்ற? -2 to 2. Then you can check the perfect reading. But input voltage I unable to measure the height. இங்க cursor யூஸ் பண்ணி நான் height measure பண்ணிருக்கேன். தெரியுதா சார்? Since you need to draw the waveform, you know the frequency of the waveform. Frequency வச்சு நீ time calculate பண்ணிக்குவ. எவ்வளவு தூரம் இந்த waveform மேல போகணும் மெஷர் பண்ணணும்ல. உன் கிராஃப்ல நார்மல் ஆர்டினரி கிராஃப்ல you need to plot these two waveform. அப்ப இந்த y axis க்கு என்ன magnitude எனக்கு தெரியணும்ல சார். For that purpose only, again you are going to select the cursor and you are going to keep the C2 and C1. Note down the C2 and C1. It is not a symmetric. கொஞ்சம் லைட்டா ஒரு ஷிஃப்ட் இருக்கு. தெரியுதா சார்? இது பாத்தீங்கன்னா 1.09 இருக்கு. இது பாத்தீங்கன்னா -1.357 இருக்கு. Take down the same reading and plot the output waveform. Output waveform வரைஞ்சிட்டேன் சார். Input waveform எனக்கு visible இல்ல. என்ன சார் பண்றது? Very simple. Again, change the setting for this minimum and maximum value setting for input value. எவ்வளவு சார் செட் பண்ணணும்? It should be in the millivolt. கரெக்டா? millivolt. எவ்வளவு செட் பண்ணலாம்? எவ்வளவு செட் பண்ணலாம் millivolt? எவ்வளவு millivolt செட் பண்ணலாம்? இப்போ எனக்கு output magnitude clear-ஆ பார்த்துட்டேன். இப்போ input நான் பார்க்கணும். So change the output magnitude into input magnitude into millivolt. ஓகேவா? இந்த டைம் நீங்களே வரைஞ்சிருவீங்க. Am I correct? இதை மெஷர் பண்ணி நீ வரைஞ்சாலும் சரி, இல்ல நீ செட் பண்ண 10 kilohertz வச்சு நீயே டைம் கால்குலேட் பண்ணி வரைஞ்சாலும் சரி. That is up to you. Okay. Then my input waveform க்கு now I am going to change the minimum maximum value into -40 millivolt and +40 millivolt. Sir, is it you can see the input waveform very clearly? பார்க்க முடியுதா சார்? பார்க்க முடியுதா?
Yes, sir.
அவ்வளவுதான். With this the whole experiment is over. நான் சொல்றதுக்கு வேணா டைம் எடுத்துக்கும். நீ எக்ஸ்பிளைன் பண்றதுக்கு it will take a very minimal time. Okay. Any doubts so far you can ask. Else we can wind up. Let me give this as a task to you people. From the frequency response characteristics, how you will find the mid band gain. எப்படி கண்டுபிடிப்ப? ஆன்சர் நானே சொல்லணுமா இல்ல நீங்க கண்டுபிடிச்சிடுவீங்களா? மிட் பேண்ட் கெயின் என்ன சார்? இந்த பர்டிகுலர் போர்ஷன்ல நமக்கு என்ன கெயின் கிடைச்சிருக்குன்னு பார்க்கணும். இது எங்க சார் பார்க்கிறது? வேர் யூ கேன் ஃபைண்ட்? கோ டு யுவர் டேபிள். இந்த டேபிள்ல ஒரு பர்டிகுலர் இன்ஸ்டன்ட்ல பர்டிகுலர் பீரியட்ல யூ வில் கெட் த கான்ஸ்டன்ட் கெயின். கான்ஸ்டன்டா இருக்கும் அந்த கெயின், மாறவே மாறாது. பர்டிகுலர் ரீடிங்க்கு அந்த கெயினுக்கு ஒரு வேல்யூ வருமா? கன்சிடர் தட் வேல்யூ as a x. That x is your mid band gain. That's all from my side. This is the time to you to practice. Try to practice. Shall we wind up?
Yes, sir.
கொஞ்சம் எக்ஸ்ட்ரா டைம் எடுத்துட்டேன், திட்டாத. உனக்கு சிம்பிளிஃபை பண்றதுக்காக தான், நீ மிஸ்டேக்ஸ் கம்மியா பண்ணுன்றதுக்காக தான் கொஞ்சம் எக்ஸ்ட்ரா டைம் எடுத்திருக்கேன். ட்ரை பண்ணி என்ன டவுட்னாலும் கேளு. I try to convert this PowerPoint into a PDF file and I will share it to you people. And what are the doubt you have it, you can refer and do it. Okay, sir? தேங்க்யூ வெரி மச். இங்க ஒரு 35 இருக்கீங்க.
தேங்க்யூ
இங்க
சார்.
ஒரு யாருமே இல்ல.
தேங்க்யூ சார்.
ஆனா ஏ செக்ஷன்ல
ஏ கிளாஸ்ல ஜாயின் பண்ண முடியல சார்.
என்னாச்சுடா?
ஜாயின் பண்ண முடியல சார்.
ஏன்?
அது அப்படியே அந்த எக்ஸிட்